This is a problem I've worked out in my book, but I like it. I really do like this problem. So it's kind of rare for me to work the same problem in the book as I do in the video. But there's a lot to talk about with this one, and yeah, I didn't want to take a lot of time to figure out one as good. So factor 35x squared minus 41xy minus 24y squared. All right, well, it's a pretty big one too. So if you could manage one like this, then you are well on your way to understanding factoring trinomials. All right, so let's, there's no common factor you can check. And so I'm going to try to break it up into binomials. And I'm going to leave some room here, kind of spread out here. Don't cramp your work. I'll try not to cramp mine. Let's take care of the variables. So x squared, I'm going to need x times x. And for y squared at this end, I need y times y. And that will produce xy terms for the middle part. So that part's done. The variables, as I say, is always the easy part to these problems. All right, well, we need two numbers here that multiply together to get 35. And so I'm going to look at 35 and pick it apart. And it's either 1 times 35 or 5 times 7. Now, it's unlikely to be 1 and 35, because when you get these big numbers, it's unusual, very unusual for that to actually work. Unless if this was very large, if the middle number was very large, then it probably would be a factor like this. So I'm going to try 5 and 7 as the most likely pair for the first terms. 5x times 7x is 35x squared. All right, so let's look at 24. There's a lot of ways to factor 24. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So actually there are 8 different possible factor pairs for this. Because there are 4 here, and there's 2 here. 4 times 2 is 8 different pairs that could go in here. And if you consider how these numbers can be juggled, that actually doubles it. So there's actually 16 possibilities here. But I've narrowed it down. Most likely it's going to be 5 times 7, because my middle number is not much larger than these two numbers. Yeah, it's fairly close, so it's probably 5 times 7. It's probably not going to be 1 times 24 either. But here's something interesting. I can immediately exclude 4 and 6 and 2 and 12. And why is that? Suppose I put 4 and 6 up there. I'm going to write it. Suppose I put 4 here and a 6 there. All right. Now you could check that and say, well, that doesn't work, because am I going to get negative 41 out of this? Well, I have 5 times 6 is 30. 4 times 7 is 28. 30 and 28 will not add and subtract to give me 41. You say, okay, well, what if we switch the 4 and the 6 around? All right, let me do that. And we're going to find that doesn't work either. So let me see, 6 here and a 4 there. This would give me 20 and 42. Between 20 and 42, I cannot get 41 by adding or subtracting. But how do I know I couldn't use 4 and 6 without even going there? It's really quite simple. 4 and 6 are both even numbers, and when you multiply an even number times another integer, you always get an even number. In this case, 4 times 5 is 20, that's even. 6 times 7 is 42, that's even. So even a factor pair in which both numbers are even are going to produce even numbers when it gets FOILed out. And when you add even numbers together, what do you get? You always get an even number. That means I cannot possibly get an odd number. All right. So if I had, again, let me run through this. And by the way, if you don't remember this little technique, it doesn't matter. But it would save you time if you did learn it. So if both numbers are even, then this number would have to be even in order for those to work. If that number is odd and both these are even, then there's no way. So that allows me to exclude 4 times 6 and 2 times 12. All right, so I'm left with what? Either 1 times 24 or 3 times 8. And let's go through a 3 and 8. as the most likely factored pair. So let me get rid of the 6 and the 4. All right. And let's see, where would 3 go? Where would 8 go? Well, one comparison you can draw is this. You know, I have, if I'm using this pair and this pair, I either have 5 times 3 and 7 times 8, or I've got 5 times 8 and 7 times 3. Well, 5 times 3 is 15, 7 times 8 is 56, 15, 56. It looks like we could get 41 out of that. In other words, we need 5 multiplying the 3. So 5 multiplies 3. And then the 8 multiplies the 7. All right, so let's check that out and see if that worked. And I'm going to write below here. This is going to be 15xy. This is 56xy. In order to get negative 41, I need negative 56 and a positive 15. So the 15 must be a positive. This must be a negative. And finally, did we get negative 24y squared at the end? I have negative 8y times positive 3y. That's negative 24y squared. So it is factored correctly. Now, let me tell you this. I can factor these in about 20 or 30 seconds. And now, like I said, I've done thousands of these. And you too could do that fast if you've done as many as I have. So this, as you build experience, you start to get a good feel for these little shortcuts and techniques, and you get a feel for factoring that will speed up your work considerably. And so that would be a pretty normal thing. But right now, if you're still kind of new to factoring, you may have to do a lot of trial and error to find the right pair that will factor it. So okay, well, I want to check my book, and I think that's probably good enough for this topic here. Just know that these require quite a bit of trial and error. And again, what's the first thing you always look for is, can you factor out a greatest common factor? Because that will shrink down the rest of the problem. So, okay, well, we'll leave it at that.